Welcome to Section 3, Video 2, Creating the Player Character's Code, Part 2, Set up Player Character. In this video, we are going to create our player character's components and set up our ammo. Under the generated body, we have added in 4 pointer variables, each with their own specific class type variable that we are using. And we are using the keyword class as a sort of forward declaration for that class, meaning we won't have to include any header files of that class, just we have the general idea that this exists somewhere. The keyword blueprint read only means that we can only get this value, but we cannot set it within blueprint code. Visible defaults only means that we can only see this value within the class defaults of the blueprint, but we cannot edit it. We have added a meta tag, meaning we can use extra features of view property, and these features allow for light scripting of the editor for that value. The meta tag allow private access means that since this variable is private, we want to be able to access it within Blueprint anyway by setting it to true. After our constructor, we will create our protected category. Here we are inheriting the begin play and on death functions from our base class, while the setup player input component function is being inherited from our pawn class. Then we are creating our ammo variables and a function that will check if we have ammo or not. The edit anywhere keyword means that we can edit this value in the editor on both instances and in the class defaults of blueprints. Here we are creating functions to modify the ammo values that can be called from another class. These are general getters and setters for our ammo, the same way it would work for getting and setting our health. Let's go to our source file, and in our constructor, we're going to start creating our components. The reason why we are having errors is because we haven't included those libraries, while in the header file, we have given the general idea that this component exists. We haven't actually given it a definition of what it actually is supposed to be, what it's supposed to do, those kind of things. And the way we do that in the source file is by going to the top under the header file for this class. In our case, it would be player character.h. Under that, and it's very important to put it under, we would include those components libraries. In this case, the location of where those header files are. For the SpringArm component, it's located under the game framework / SpringArm component, and so on. These are our libraries that we would need to be able to access each component's code. And in the case of the skeletal mesh component, we would need the library for skeletal mesh components. And here we are creating our components and saving their locations in memory so that we can access them later using our pointer variables that we created at the top of our player character header file. It is very important that you must always set up attachment for those components, or else the engine will crash, as components are required to have a parent. We are then setting some default values for our components. In the case of SpringArm, we are setting our relative location, a target arm length, which is how long the camera's spring arm is, turning off collision test, setting our pawn rotation to be true, meaning it will use the control rotation, not a separate one that we would have to set for the spring arm separately, and setting what we can and cannot inherit from that pawn rotation. The f vector is actually just a struct for x, y, and z values using floats for each x, y, and z value. For our camera, we are setting its field of view to a regular value of 90. After we create our components, we are then setting the default values for our variables. You may notice that we are using max health and current health again. This is because it is protected and allows us to change the current value of this subclass. Back in our header file, let's add definitions for our begin play, setup player input component, and on death implementation. Instead of having to do the long way, which is copy the name of the variable or function and pasting it back into our source file and repeating a very tedious task, we can actually select it with the cursor or press Ctrl+, which will show our options or additional actions that we can use, and select create definition of this function inside of our source file. And it will automatically set that up for us. And we can close this and repeat that process for each one. Once you finish that, we'll go back into our source file. Select Save All to save those changes. And let's start it on our begin play function. Here we are doing what we did with our health in the base class, but for our ammo, And we are calling super begin play, meaning since it is virtual, this allows us to call each iteration of begin play up the chain at once, as it is generally good practice to call super and then the name of that same function inside of that function. Thus it will go up the chain to its parent, and up the chain to its parent, and up the chain to its parent version of that same function, and so on and so on. In our setup player input components, we are doing the same thing by calling the super version of this function, and then adding a specific special kind of if statement called check. And what this is a macro that will cause the program to crash if it is false. And this is a sort of very strong if statement where we need this to be true and only true. For on-death implementation, we don't need anything currently, so we will leave that empty. Back in Unreal Engine, let's select Compile to compile that code. While this is compiling, let's add a folder in the Content folder for blueprints. Go to Content, right-click, and select New Folder. As you can see, our compile finished, and enter Blueprints. This is where we will save all of our subclasses from our C++ to Blueprint classes. Let's go back to our C++ class, right-click on Player Character, and select Create Blueprint Class based on Player Character. Let's place it in Blueprints folder, and name it Player Character _BP. This is the Blueprint editor. At the top is our Compile button that has to be pressed for the game to run, and we would have to press this every time we make any changes to any values within this blueprint, whether it be blueprint code or any base values in our class defaults, where we can find all of our values that are editable within the editor. Here we have our components that we created within C++, and they have been automatically added and set to their locations. The viewport works the same way as it does within the level viewport. Construction script is a special blueprint graph that fires off from construction script's beginning node that cannot be deleted and happens after the object has been created or spawned, and then runs the C++ code and then runs the construction code afterwards, because C++ always gets priority in those cases. To move around within the graph, right-click and drag. To add any nodes, just simply right-click, and left-click anywhere else to get rid of that. The event graph is the same way, but for any other general functions or events that need to be fired. Construction script is specifically for construction script code that is meant to be fired when this object gets created. An event graph is for anything else. In the next video, we will be creating the player character's code, part 3, basic movement.